Very good morning, friends. Today we will see another problem on the lateral surface developments. Those who are watching my video first time, please subscribe my channel, share the video for latest updates in computer aided engineering graphics, and don't forget to like. Let's begin with the problem. Draw the development of the lateral surface of a truncated vertical cylinder, 40 mm diameter of base and height 50 mm. The truncated flat surface of the cylinder bisect the axis at 60 degree to 8. This is the given problem. So here we need to develop the truncated vertical cylinder. As you know that a vertical cylinder, the front view is a rectangle and top view is a circle. So diameter is given 40 mm and height is given 50 mm. Let us construct the front view and top view of a vertical cylinder and introduce the cutting plane. To convert vertical cylinder into truncated cylinder, the cutting plane will bisect the axis at 60 degree to 8. That's the condition is given. Let us draw an XY line, horizontal XY line somewhere somewhere here. I will draw an horizontal XY line. Okay, now let us construct the top view. Top view is a circle. Top view is a circle of diameter 40 mm. So I'll construct a 40 mm diameter circle somewhere here. This should be 40 mm. Okay, I constructed this. So now the next step is, let's divide the circle. Let us draw the projection lines or vertical projection lines. From here, draw projection lines till XY line. From the center, draw projection line till XY line. From this circumference, draw projection line till XY line. It should be 90 degree line. Okay, now the height is given. The height is, look at the height of cylinder is 50 mm. From here, mark the length is 50, angle should be 90 degree. So I got a cylinder height that should be 50 mm. So this should be 50 mm. This should be 50 mm. Now let's complete the front view. Let's complete the front view. Vertical line. Then again from here, it should be, length should be 50, angle should be 90, and let's complete this. So this is the front view of the vertical cylinder. Now I will divide the circle into 8 equal parts. Let us divide into 8 equal parts. I'll go to line command. From here I'll draw an horizontal line like this. Now I'll go to pattern. Circular pattern. So let's check where is circular pattern. I'll go to circular pattern. Let's select this and I'll go to circular pattern. Number of count is 8. Angle should be 360 degree. Press enter and keep this as center. This is the center and click on finish button. So I divide the circle into 8 equal parts. It is 1, 2, 3, 4, and then back side is 4 parts. Now let us go with naming. Let's go for naming. So I'll go to text. Let's keep font size 3 mm, and I'll say this is point A. This is say B. This is say C. This is D. This is E. this is F, this is G, and this is H. Okay. Now let us draw projection line from all the points. So from A I drawn projection line, from B and H draw vertical projection line, from C and G draw projection line, overlap with axis line, from D and F draw projection line like this, from E draw projection lines. Okay. Now the next step is we need to introduce a cutting plane. We need to introduce a cutting plane which bisect the axis at 60 degree to 8 bisecting exactly at the middle. So we need to construct a cutting plane. Let's go to line. And you can use cutting plane. This is the cutting plane. So exactly at the middle you need to draw. Exactly at the middle, let's draw an inclined line like this. It should be inclined at an angle of 60 degree. It should be inclined at an angle of 60 degree. Look at the angle. The angle should be 60 degree. It should be inclined at an angle of 60 degree. So this angle should be 60 degree. Let's go with angle between this and this. It should be 60 degree to 8. With respect to axis, it should be 60 degree inclination. Now let's extend this. Extend the cutting plane. I'll go to extend. Let's move on to the extend command. And I'll extend this, I'll extend like this. Okay. So now the extra lines, I'll trim the extra lines. I'm trimming these extra lines. Okay. Now these lines should be thicker line. So I'll go to line command. Let's zoom this. I'll go to line command. So choose thicker line. From this should be thicker line. This. So use continuous line. And this again from here to here it should be thicker line, then from here to here it should be thicker line, then from here to here it should be thicker line, then from here to here it should be thicker line. So these lines should be thicker line. Okay. Now the next step is let's go for naming. So this is, I'll say A of A1. This is A. This is the A1 or A1. Let's keep this is capital A, and this is A1. Keep this is B dash of, sorry, this is, I'll say this is A dash, A1 dash. This is A dash, small letter, let's use small letters, A dash, and this is A1 dash. This is B dash of H dash, B dash of H dash, and this is C dash of G dash. This is D dash of F dash, and last one is E dash. So this is B dash of H dash, this is C dash of G dash, this is D dash of F dash, and this is E dash. Similarly here E1 dash, B1 dash of H1 dash, C1 dash of G1 dash, D1 dash of F1 dash, and E1 dash. Okay. Now again this is, I'll say, point 1, and B and H, this is 2, this is 3, this point is 4, this intersection point is 5, again this is 6, this is 7, and this is 8. Okay, now let's draw projection lines, horizontal projection lines. So I'll go to line command, use thin line. From here draw horizontal projection lines. Somewhere here you draw vertical projection line. Now the length of the cylinder is L is equal to pi into D. So length of this cylinder, L is equal to pi into D. L is equal to this is pi into D. Let's go with pi. Pi into it should be diameter of the cylinder. This is the formula. So if you apply L is equal to pi is 3.14 into diameter of the cylinder. Diameter of the cylinder is, so the diameter of the cylinder is 40 mm, 40, and let's type L is equal to, so reading 3.14 into 40 mm, so that gives 3.14 into 40, so 125.6 here in terms of mm. This is the given length of the cylinder. Use this formula to find the length of the cylinder. This is the length of the cylinder. So now we need to construct a line. We need to construct, let's move on to offset. So we'll go to offset. I'm offsetting this line. The distance is, let's take round figure 125, 126, and press enter, click. So this is 126. Okay, I'll make round figure. Let's make it 126 mm. Okay, I got 126. Now this one you need to divide into 8 equal parts. So 126 by 8. So we are getting 126 by 8. 126 divided by 8, that gives 15.75. So I'll go to again offset. I'm offsetting this 15.75. Press enter. Then press enter. Like that you can divide into 8 equal parts. Okay. So I divide this into 8 equal parts. Now the next step is draw the projection line. So now this is capital A. Let's take A. This is B. This is C. This is D. This is E. This is F. This is G. This is H, and this is E. Back to E. Okay. Okay. Now let's draw horizontal projection line from all the point. From 1, I draw horizontal projection line. From 2 is here, to 2B. From 3, this is 3 to C. This is 4. From 4 to D. Then from 5, this is 5. From 5 to E. Then 6 to F. Then from 7 7 to G, 7 to G, then from 8 to H, then from 1 to A. Now join all the points. You will get development of a truncated cylinder. I'll join this 1 1, okay, 1 and 2, this is 2, okay, next 3, this is 3, okay, this is 4, okay, this is 5, okay, this is 6, this is 7, this is 8, this is 1, and let's make a complete development of this truncated cylinder. This is the development of a truncated cylinder. Now this is 1, this is 1, this is 2, this point is 3, this point is 4, this point is 5, this is 6, this is 7, this is 8, this is 1, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and this is 1. So this completes the lateral surface development of a truncated vertical cylinder. Thank you so much for watching my video. Thanks a lot.